Study Session 4. Sampling. Introduction. This study session will expose you to the meaning of sampling and the various techniques of conducting sampling, specifically in some science research setting. Learning outcomes. When you have studied this session, you should be able to 1. Use sampling techniques. 2. Differentiate between probability and non-probability sampling techniques. What is sampling? Sampling is the process of taking or selecting any portion of a population or universe scientifically as representative of that population or universe. A representative sample is one which has all the characteristics of the population under study. A selection technique in which every member of the population has equal chance of being selected is called random sampling. On the other hand, a selection technique in which the members of the population do not have equal chances of being selected is called biased sampling. Each member has a higher or lower probability of being selected than others. Important concept in sampling. Sample frame. By sampling frame, we refer to a list of items in the population from which the sample is drawn. For instance, the names of all undergraduate students in the University of Ibadan could stand as a sampling frame if the population is defined as undergraduate students of the university. To select the sample randomly, we need a complete sampling frame. Sample size. It is the total number of items in the population that is actually selected for a research. The sample size in the example given may be 200 undergraduate students of the University of Ibadan. The sample size desirable for any given research is determined by the sampling frame, the reliability of results expected, and costs of managing the sample. Generally, however, the greater the sample size, the higher its reliability and accuracy, but the higher it costs. This is because a larger sample size increases the representativeness of the population characteristics, but it could be more difficult to manage in terms of conducting the research. Sampling techniques. These are the methods used to select a sample for a research. There are two main techniques for selecting samples. These are probability and non-probability sampling. Probability sampling. In this case, some forms of random sampling are used in one or more of their stages. Non-probability sampling. Non-probability techniques do not use random sampling. Probability sampling techniques. A. Simple random selection. By this technique, all members of interest have equal probabilities or chances of being selected. A common method adopted is the use of table of random numbers. The table of random numbers is generated by the computer and contains decimal digits of 0 to 9. In usage, the researcher should first prepare the sampling frame by listing all members of the population in alphabetical order and number them serially. The sample size is decided before entering the table of random numbers. To start the selection, the researcher enters the table at any point without bias. To ensure objectivity, the researcher may close his or her eyes and just touch any member with the tip of a pencil. The random number digits can be read sideways, horizontally, or up and down, vertically, from this starting point. The number of random digits to select depends on the members of the population in the sampling frame. If they are between 1 and 99, then 2-digit random numbers are selected at a time from the table. The serial numbering of the members of the population in the sampling frame would range from 01 to 99 to reflect what would be observed on the table of random numbers. A frame having members up to 999 requires the use of 3-digit random numbers. Thus, the serial number should range from 001 to 999. A selected random number is taken as the serial number of the corresponding member of the sample frame in the population, and by inference, that member is included in the sample as a participant. This exercise continues until the total number of participants desired for the research is exhausted. When a number greater than any in the frame is selected, it is discarded and the process continues until the sample size required is obtained. Another method of simple random sampling is balloting. By this method, members of the population are also arranged alphabetically and numbered serially. Numbers are then written on pieces of papers to cover all the numbers in the population. Each number that is written on a slip of paper is folded and kept in a container. After all the papers are folded and placed in a container, the papers are shuffled, after which selection of papers from the container is made to cover the sample size. Each selected number is taken as the serial number of the corresponding member of the population. The member is thus included in the sample. B. Stratified random sampling. In stratified random sampling, the population is divided into subgroups called strata. Each stratum is defined by unique characteristics of each subgroup in the population. In a population, we may have our strata as males and females, blacks and whites, junior employees and senior employees, and so on. Within each stratum, simple random sampling is used to select participants who will be included in the sample. Hence, it is called stratified random sampling. This sampling technique is used mostly when a researcher notices that some peculiar features of the population have to be adequately represented in the sample, which may not be achieved if the simple random sampling technique only is used. The simple random sampling may not reflect the heterogeneity of some populations. By dividing a population into distinct subgroups or strata, with each stratum differing from others, internal homogeneity within each stratum is ensured. Employing the simple random selection technique in each stratum presents a sample which reflects the heterogeneity of the population. Such sample is therefore a better representative of the population. To improve on the heterogeneity of the population while adopting stratified random sampling, researchers may decide to select equal number of participants from each stratum, or the selection may reflect the ratio in which strata exist in the population. For instance, regardless of the number of males and females in the sample frame, a researcher may decide to select just 20 males and 20 females as the sample. On the other hand, if he or she had 300 males and 100 females in the sample frame, this gives a ratio of 3:1. In selecting participants for a sample size of 40, using the simple random sampling in each stratum, he or she could select 3/4 of 40, that is 30 males, and 1/4 of 40, that is 10 females. The 40 participants needed will therefore mean 40 males from the 300 available and 10 females from the 100 available. However, the stratified random sampling is not adequate where a sampling frame does not exist or cannot be easily compiled. For instance, having a sampling frame for the population of Nigerian youth may be rather difficult. Also, when a sample frame exists but members of the population are so scattered that one may not be able to clearly spell out a stratum as distinct from another, then the stratified random sampling is not adequate. C. Cluster sampling. Cluster sampling is best used when stratified sampling cannot be used. It is a multi-stage sampling technique that requires successive random sampling of the target sampling unit or set the subset. It is a multi-stage sampling technique that requires successive random sampling of the target sampling unit or set and subset. It can be a 2-stage, 3-stage, or more exercises. For instance, states in a country can be randomly selected. The towns, streets, family, individual household, and individuals in a household may be subsequently selected. D. Systematic sampling. Systematic sampling entails the random selection of the first person and successive persons at a particular interval, called the nth interval. It starts by the alphabetical arrangement of all members of the population and serial numbering of these. By this, the total numbering of the sample frame is determined. The researcher then decides on the sample size for his or her research. To determine the nth term for random selection, divide the population size by the sample size desired. Thus, if the population size is 100 and the sample size desired is 10, then the nth term becomes 100 divided by 10, which is 10. In selecting participants for the sample, every 10th person in the sample frame is selected. Thus, the 10th, 20th, 30th, 40th, 50th, up to the 100th member of the frame are selected to make the sample. This will finally give us a total of 10 participants at the sample size. Non-probability sampling. A. Accidental sampling. It is the weakest form of sampling, but the most frequently used in survey research. One simply takes available samples at hand rather than embark on the laborious process of obtaining a probability sample. A good example is the distribution of research questionnaires indiscriminately to people as they are found. Also are interviews of persons on the street by news reporters. This technique is used when both time and money are limited. It is quick and easy to conduct accidental sampling. However, there is limitation of generalizing the result of the sample to the entire population. The results and interpretation are limited to the sample. B. Quota sampling. Quota sampling is the most systematic and scientific of the three non-probability sampling techniques. It involves dividing the population into a number of segments, just like the stratified random sampling. However, unlike the stratified random sampling, in this case, researchers arbitrarily select a quota sample from each segment. Thus, selection is not random, so quota sampling does not ensure the selection of a representative sample. Despite this shortcoming, quota sampling remains an attractive alternative to stratified sampling. C. Purposive sampling. This is characterized by the use of judgment and a deliberate effort to constitute a representative sample by including presumably typical areas or groups in the sample. Thus, the degree of representativeness of the sample depends on the good judgment and luck of the researcher. However, results from such sample may not be accurate reflection of the population characteristics. Study session summary. In this session, you learned that sampling is the process of taking a representation from the population as research participants. Random sampling was explained as a case where every member of a population has equal chances of being included in a sample. This was differentiated from biased sampling, where members of the population do not have equal chances of being selected. A sample frame was differentiated from sample size, the former being the total unit in the population, while the latter is the number of participants selected in a study. Two broad sampling techniques were differentiated: probability and non-probability sampling techniques. While the former adopts some forms of random selection, the latter does not. Types of probability sampling techniques presented include simple random, stratified, systematic, and cluster sampling, while non-probability techniques include accidental, quota, and purposive sampling. End of session 4. Thanks for listening.